Hi, and welcome to the latest devlog for Toast Engine, my hobby-built game engine focused on large-scale planet rendering. At the same time, I'm developing a game called The Next Frontier, where the goal is to let players colonize and eventually terraform Mars. This is actually my first project in both graphics programming and game development, so a big part of this journey has been learning by doing. I've been working on it for a couple of years now, alongside my regular job, which means progress is steady but not rushed. These devlogs are my way of documenting that journey and sharing the progress with you. There is no fixed schedule, I release them when there is meaningful work to show. If you enjoy following long-term engine and game development, consider subscribing. Now let's dive into the latest updates. Shadows are done! And instead of using a single shadow map as I used to do, I'm now using something called Cascading Shadow Maps, or CSM for short. If you remember, and as you can see on your screen right now, I used to have a sunlight frustum. That's the yellow box, and I could push the size of this box to around 1000 by 1000 meters before precision issues completely broke the shadows. Outside of this box, object wouldn't cast shadows, and when you have an open scene, as I do in the terrain, you would like shadows to be cast as far as the players can see. The problem is that a single shadow map has limited resolution, so when you stretch it over a very large area, you lose details and start getting shadow artifacts. Even with an 8K texture, I got issues with a sun frustum larger than 1000 by 1000 meters. Cascading Shadow Map fixes this by splitting the camera view into multiple depth ranges, or cascades along the Z-axis from the light point of view. Each cascade renders its own shadow map, covering only a portion of the view frustum. That means the cascade closest to the camera gets a very high texel density. We can see that if you go move close to a shadow here. Sharp shadows. While the distant cascades cover much larger areas with lower precision. If we go over here, the shadows now have a lot lower precision, but it doesn't matter because it's far away from the player, so we won't notice it. So instead of wasting resolution far away from the player, we distribute the precision where it actually matters, over here. You can almost think of Cascading Shadow Maps as a kind of level of detail system for shadows. Right now, my engine only supports the sun as a light source, and we can see the sun moving over here. This is by far the most important light in an outdoor Mars scene, but in the future I do want to support additional dynamic lights. After all, the colony still needs to function during night as well. With Cascading Shadow Maps, I can now push the shadow distance to 10,000 meters. So we can move the object here far away and it will cast shadow. It have a lower precision now, but doesn't matter because it's far away from the player. If you look hard, you can see that the shadow gets more and more blurry, and that's because the cascades at this point covering a much larger area, which lowers the precision. Doesn't matter for us. And you can see, we can move it all the way up until it doesn't really matter anymore. I could most likely lower the shadow distance if we look it in from this point of view. And now, the shadow, oh, it's actually still rendering. Yeah, you can see, it doesn't matter. We can move it far away, still cast shadows even when it doesn't really matter. So at that scale, the projected shadow is only a few pixels, so eventually it will go away because it doesn't really matter to the player. But I don't need to render a sunlight frustum anymore, because from the player's point of view, the whole scene will be lit. Even though shadows aren't cast, if I push this if I move this far away, I can't even see it now, so it doesn't matter if it casts shadows or not. Let's move it back. These new settings I have for Cascading Shadow Maps can be found here in the Scene Settings panel. We have cascade counts, currently set to 4, which seems to be a pretty common industry standard. More cascades improve quality in the distance, but they also increase the rendering cost since each cascade requires its own shadow pass. We have distance. This controls the total shadow coverage range. This is what used to be 1000 before. I found 10,000 to be a good number to start off with. I might tweak it in the future, but right now it works. We have the lambda value here, and this decides if this value is 1, this determines how the cascades are split up in the shadow distance. So if lambda is 1, that means that we use a logarithmic split, and 1 means full logarithmic split basically. 0 means instead we use a uniform linear splits across the shadow distance. We also have constant bias. The offset is applied to the sampled shadow depth to prevent self-shadowing artifacts, often called shadow acne or Peter panning. We also have a slope scale bias down here. This adjusts the bias based on the surface angle relative to the light, which helps reduce artifacts on grazing angles without over-biasing flat surfaces. Together, these two constants, or these two biases, becomes the final bias that is then used for the shadows in the lightning path shader. These values are also something I most likely need to fine-tune in the later, but for me it's a good starting point. They work good together for now. I hard-coded my shadow maps to 4K resolution. That is something I might make into a setting in the future. The previous one was 8K, also hard-coded. But since I use 4 cascades now, it's actually 4K times 4 in terms of memory, which means in the end double the memory than before. And I also have another thing that I didn't get working before, and that is objects casting shadows on each other. They didn't used to do that, so if we move this, let's find a good spot where it actually... You can see here now we have shadows being cast from this starship to this starship. And again, there is some flickering going on here, which I need to work on, but I think it's a great improvement. One final detail, and that's about the terrain shadows. They use a different technique, so they aren't really limited by the distance limitation in the Cascading Shadow Maps. I do some kind of ray tracing here, but at the moment they don't really work. So I have to look into that in the future. But in this, I just wanted the Cascading Shadow Maps to work correctly. So we can see here the sun goes down and the shadows still works. Yeah, so I'm super happy about that. Shadows done. With Cascading Shadow Maps done, that means that I'm completely done with my version 0.3. As I've said, this is just a way for me to structure my work and has nothing to do with any kind of official release or anything. Instead of me reading everything I've done in 0.3, I'm gonna just post them quickly here on the screen, and you can pause if you want to read them. And now with that means I'm heading into version 0.4, which I have a lot of nice things planned. Again, if you want to read them, pause, but I'm just going to post them quickly here. And with that, let's dive into development and the things I've done for version 0.4 so far. Version 4 means 2 new models to be created, 1 rover and 1 starship. And that meant going back to Blender, something I've been waiting on for a while, and starting working on the new version of Starship. That takes a lot of time because there's a lot of new functionality that I'm adding, animation, new parts, new materials that I'm adding. So that's several weeks of work. But I wanted to do something quick, something that would be rather easy to implement and something I could check off the list in version 0.4, and I decided to go with friction in the physics engine. So if you look on your screen right now, we basically have what the engine used to be before friction. You can see the Starship falling. I've removed the landing scripts, and with no friction the Starship lands and it starts to spin. And it will keep spinning, it will never stop spinning, because the physical engine have no friction. And what you see on your screen right now is the updated Toast engine. Landing script is removed from Starship as well, and friction is now implemented with something called the Column model. And it has two friction values, the static friction and the dynamic friction, which we can find in the rigid body component. The static friction is basically the point where object starts to slide. And the dynamic friction is the resistance to that slide. So once it starts sliding, it's going to have a resistance, and then that's going to kill the velocity or the motion, and eventually it's going to move up above the static friction again, and the object comes to a standstill. So if we press play here now, landing script is once again deactivated or removed. We can see the Starship falling. It has a weird angle, so we know it should spin if we have no friction, but we do. So what happens? It slides a bit, but then it stops pretty quickly. And these values is something I can play with. The most important part is that friction is now in the engine and nothing will spin forever again. So I love it. It went great. No major issues implementing it. And now I'm right back to Blender, keep working on Starship version 4. Now I'm done with the pretty small improvements. I've implemented the ability for the planet renderer to use Albedo texture and not just a plain color as we've been using so far. And I've prepared the rendering part here of the planet panel to have Albedo texture, and you can use that map, Albedo map here. Otherwise we use the plain color as we're doing right now. So this is how it looks before. Basically it's a very brown reddish color that is the same for all over the whole planet. The only thing that mixes this up, if you go out to orbit here, is the atmospheric scattering is doing some things here depending on the depth or the height. So the higher up, the less scattering. That's why you can see the valleys are a bit grayed out, and I think this might actually need some improvements in the future as well, but it's okay for now. We also have the normals acting on the terrain to give them different lighting conditions. But if we look at maybe something very high up, like here for example, where you just have a very flat area without any, and it's also far away enough for the planet so it doesn't have any details as we have close to the player camera. So it's very flat, and you can see it just have that plain color. There's nothing acting upon it, and that's what I want to improve with my planet with the Albedo texture. So we're back down on the surface. I did some bug fixes, some improvements to the code, because when I first implemented Albedo map, it looked a bit not better, is how I would put it. But here we are now, and you can see the still plain color, but now we can activate the Albedo map, and all of a sudden we get a different color. Here down at the surface, this might actually be a bit too bright, and I think this has to do with the atmospheric scattering that I need to revisit. But if we zoom out a bit here, it starts to look better. I thought, like when I first saw this, like, okay, this is not perfect, I need to do something. I think the thing is that down, like when you're maybe here, is where you would start to see terrain details coming from the procedural generation. Right now it's just very close to the camera, so that is something I'm gonna update during this version as well. I'm gonna fix that. But I also implemented something pretty cool. So if we move up a bit up here in the atmosphere, I added 3 values here to the rendering settings for the planet, where you can like, you can set, you can see here slope gets darker. So I found that if you put this at 90, maybe you can do the threshold, and then slope darkening would be, I don't know, maybe like something like, you can play around, you can see here. So this actually enhances the slopes, and I can decide like the sensitivity, so the lower it is, the steeper it needs to be. You can go even very high up, but I think I found that around just below 20 is good. And then the threshold is basically also, can't remember what it is right now, but the darkening is how dark you get. So 0 you get completely black, and 1 is no color at all. So I can play around with this value as well, and you will see that I have enhanced the slopes so they look a bit steeper than the terrain data or the height map actually tells them that it is. And this I think looks really good. I mean, maybe we need to lower that one a bit, or do we need to increase it maybe? Make that a bit. So yeah, I can play around with this, and I get it looks steeper than it actually is from far. So yeah, and you can also see some artifacts here from cube mapping that I need to work from. So I think it looks a lot better now than it used to do. I'm pretty stoked about it. But as I said, in the mid distance level, I need to do some work to actually start adding details a lot earlier than I used to do. That is Albedo map, done and done. I have now been working for 2 weeks creating the new Starship model, what I call Starship version 4, and that's because I've basically iterated over this for 4 times now. The first one was just a plain cylinder that I tried to import. The second one had a nose cone, and so on and so on. So what you're looking at now in front of you is the 3rd version that I've had in the engine for about a year now. It had the ability to do animation, it can start its engine. So yeah, but now it's time to introduce version number 4. I'm not fully done, so this will be the first part where I present it. The second part will have animations, which I haven't implemented yet for LOD groups, which was something that was new for version 3 as well. So this have different, like if I move this further away on the screen, actually it's easier to move you can see that it gets less details. So it has 3 LOD groups. So this is the plain one. I remember when I did this in Blender, I had a hard time. It was actually pretty boring, and that's why I think I worked in the wrong way. Normally when you work with assets for a game, you start with a very high poly one, and then you deconstruct it or something. It has a name I can't remember right now, to make the lower level LODs, and you bake it with normal maps and everything. I don't do that because my models are so big. Starship is 50 meters tall, which is huge. So yeah, it was time to work some in Blender. I spent 2 weeks. This time it was much more enjoyable. I think I remembered more about how I work in Blender than I thought I would. I used some new techniques. So overall, really fun actually. And we have Starship version 4 here in the hierarchy. I can move it into the view, and here you have it. Let's put this one next to each other like that. And what you see here is the highest LOD for both. You will see some vents. They are actually, in reality, they are stainless steel, so they are not black as they are in my engine, but this was an artistic choice because I wanted them to be more obvious than they actually are. My renderer wouldn't be able to give the correct color details and everything to make them appear. Basically, they would be almost invisible. So I made them black by choice. We have some landing legs here. As I talked about before, the animations are not in yet, which means that the landing animation I can't do, but this will unfold when it lands. If we go even closer, you can see the stringers, and this is also like my engine. I'm not sure actually if this is the correct way to do things. You can see the flickering happening here. So that might, but you can see now we have well lines. Might not be perfect, but compared to the other one, this looks a bit more interesting. This is also, you have the forward flaps moved. They are they're updated for, what do they call it? Version 3, I think, is what they call it at SpaceX. Version 2, their version 2 even have the flaps at this location. We have some reaction control. The antennas are moved, and this one actually have payload store. You can actually see it here. I screwed up in Blender a bit, but I can't be arsed at this point to fix it. But these have payload store that's gonna be able to open and unload cargo, which is something, it has to do with animation, so that's coming in the second part. But overall it looks a lot better. I got the Albedo map for the heat shield working, so that as well looks a lot better now. It's easier to see that it's actually a heat shield if you compare it to the old one, to the right there. Another thing where I spent a lot of time, yeah, these flaps will be movable now. I can actually, I think I can do that now if we go to a flap. I think those are, yeah, you can see it's actually moving. So yeah, work in progress here in terms of, like, you can see the attachment points looking weird, but yeah, it works, which is kind of funny. If we go here to version number 3, my old one, and just flips it on the side, we can see the engine bay. Engine looks a little bit boring, not very, and there you have the old landing legs as well. But if we do the same to the new one, oh, wrong axis, have a different axis, like that, we can now see that the engine bay looks a lot more interesting. And what is funny here that I implemented a second way of doing animations. So I've had implemented before that you can animate through Blender, but sometimes that is very like specific. You want to unload cargo, you know, it does the same thing every time, but sometimes you want to animate specific parts, rotate specific parts of the mesh. So if you look at the engine bay now, actually I think we need to, yeah, we can do this, and we go up to it instead. You can see that it's actually animated now. So this is a thrust vector control test. You can see the shadows are a bit off as well, but so this is a thrust vector controller. This is what we will use to flip the ship, which is part of what I'm trying to achieve here in the next couple of weeks. Have it come down and then do a flip landing with the legs unfolding and then unload some cargo. That's the plan, at least. Yeah, so that is the first of 2. I'm gonna have this in the next devlog as well, but I'm gonna talk about, hopefully have animation running, if not in the next devlog, the one after that. But in the version 0.4, the animation is gonna play out. So that the milestone I have right now is for this Starship to be able to do a flip landing. And it's gonna have air resistance acting upon it while it falls through the atmosphere. It's gonna land and it's gonna unload a rover. So that is like the next big milestone for me in terms of the game, and that the game engine will be able to handle that. So I'm super happy. It was nice to see that it was fun to work in Blender and not boring as with it was very tedious with version 3. Version 4 was a lot more fun and I learned a lot. So yeah, great. Thanks for watching this far. If you made it to the end of the video, thumbs up to you. I will go back to developing version 0.4 and hope to have the next video out in the not too distant future. Hope to see you again. Bye!